I have a few problems that I wanted to demonstrate. So these are just some various, you'll notice the titles. I left the titles on these. Finding the perimeter or area of a rectangle given one of the values. So I chose one of each, one to find its area, the other to find its perimeter. So the first thing I like to do is draw a rectangle, and then I look at the problem to see what I know. So it says the length of the rectangle is 6 meters longer than the width. So for me to be able to find the length, I have to know the width, and then if it's 6 meters longer than the width, then I could add 6 and get the length. So the base thing that I don't know is the width. So I'm going to put a W for the width, and then I know that the length is 6 meters longer than that, so the length is W plus 6. And this problem tells me the perimeter is 36, and I know perimeter is going around, so I need all of the sides, and the total of all those sides will be 36. So W plus 6 plus W plus W plus 6 plus W, that's going all the way around, is equal to 36. So that's W plus W plus W plus W, that's 4W. And then 6 plus 6, that's 12. And so 4W plus 12 is equal to 36. And so now I can subtract 12 from both sides, and I get 4W is equal to 24. I divide by 4, so I know that the width of this rectangle is going to be 6. So if the width of the rectangle is equal to 6 meters, then the length is 6 plus 6, so the length is 12 meters. So now I know my width and my length of my rectangle, so I can find the area. So remember the formula for area, it says that I'm supposed to multiply the length and the width. So for this one, the area would be 12 meters times 6 meters. 12 times 6 is 72. And meters times meters is meters squared. So the area would be 72 meters squared. Now the problem has the same direction, but instead of finding the area, sometimes we're asked to find the perimeter. So this is the same title block. So when you're working these and you're looking in your carousel, you can see them. But this time we're going to start off with the area, and we're going to break down and find the perimeter. So once again, I'll draw a rectangle, and I'll read my question to know what I know. So the length of the rectangle is twice its width. So remember, I'm starting off with the width again. It usually comes at the end of the sentence where you start. So I start off with the width, so I put a W, and then the length is twice the width, so that means 2 times. So the length is 2W. So this time, eventually I'm going to find the perimeter, but the problem gives me the area. And I know that area equals length times width. And I know that the length times the width is 162. So the length times the width is equal to 162. So now I get 2W squared is equal to 162. So I have to get the variable by itself, so this is multiply, so let's divide. So that gives me W squared is equal to 81. So if W squared is equal to 81, then W is going to be the square root of 81, and the square root of 81 is 9. So when I come back up here, I know that my width is equal to 9 feet, and so my length is going to be equal to 2 times 9 feet, which is 18 feet. Okay, so once again, I know my width and I know my length now, but this problem asks for perimeter. So I will have to take the dimensions of the rectangle, and so my perimeter will be equal to 9 feet plus 9 feet plus 18 feet plus 18 feet. And so 9 plus 9, that's 18, and then 18 more, and then 18 more. So that's like saying 18 times 3, and 18 times 3 is 54. So the perimeter is equal to 54 feet. So those are examples of finding the perimeter or area of a rectangle given one of these values. I did two separate problems. Okay, so let's look at another type that I've noticed in the homework that a lot of students are getting. The title of this one, writing a function rule given a table of ordered pairs, two-step rules. So you'll notice you have an input-output. When it was a one-step rule, you guys probably thought it was pretty easy because you either added or you subtracted or you multiplied or you divided to get from the input to the output. But this time you'll notice it says two-step rules. So it's a little different, okay? So I think that the easiest way to do this one is to find what we call the change, okay? The change. So if I go from my input to my next input to the next input and so on, I'm adding 1 each time. 1 plus 1, 2 plus 1, 3 plus 1, okay? To get from 12 to 16, I would have to add 4. To get from 16 to 24, I would have to add 4. And to get from 20 to 24, I would add 4. Okay? So what we call our constant rate of change it's 4, the output, over 1, the change in the input. So our constant rate of change is 4. Okay? So that means that that's our multiplier. So whenever we get done with this, it's going to be 4n because it's a multiplier. 4n, 4 times n, 4n. Now we have to next say, well, okay, do we have to add or subtract anything by that 4n to end up getting our output? So this is our input, okay? We know that it looks like we're going to have to multiply 4 times all of our input values, but the next question is, do I have to do anything else? So if n is equal to 1, if I put 1 as my input, okay, so this would be 4 times 1, which is just 4, but my output was 12. It says my output was 12. Well, if I put 1 in, if my input is 1, okay, I only get out 4, but my output's supposed to be 12. So I'm missing a piece right here. So you usually have to add or subtract something in order to get to your output. Okay? So in this case, I would have to add 8, and that would get me to my output of 12. So I put in 1, okay, so 4n plus 8. So I put in 1, so that's 4 times 1. 4 times 1 is 4, and 4 plus 8 is 12. Okay, let's see if it works for the next one. 4n plus 8. So if I put in 2, so that's 4 times 2 plus 8, so that's 8 plus 8, and 8 plus 8 is 16. Oh, 16. There it is. Okay. So I know that I need my multiplier, but from that multiplier, then I know that I have to add or subtract something in order to get there. So if this piece confuses you like this, you could find your multiplier, easy enough. So that's 4n, because you know you have to multiply it, right? And then plus, we can call it b, and then that has to be equal to our output. So we'll use this first one. So we'll say 12. So my input is 1, Okay, so 4 times 1 plus b equals 12. And that's my output. So this is 4 plus b equals 12. Subtract 4. So b had to be 12 minus 4, which is 8. So that's what I needed to add in order to get my outputs. Okay, so that's one example. I found 2 more problems that I thought you guys might want a little bit of help with, and this one was, the title was identifying independent and dependent variables from equations or real world situations. Okay, so the question is, you're trying to figure out which one is either dependent or independent. It depends on what your problem asks for. So what do we mean by independent and dependent variables? Okay, independent means, you know, that guy is independent, like your parents are independent, but you are dependent upon your parents. So dependent, if you look at a linear equation in slope-intercept form, the x is what we call the independent variable. Independent variable, because that is the value that you're going to plug in first, and then once you do all this calculation, the y, we call it the dependent variable, because y depends on what I put in for x. Okay, so if we look at this first problem, it says a person's muscle mass changes with age. Muscle mass increases into young adulthood and decreases after. Which is the dependent variable in this relationship? So, which depends on the other? Does your muscle mass depend on your age, or does your age depend on your muscle mass? Well, your age is independent. If I'm 12, I have a certain muscle mass. If I'm 50, my muscle mass changes. It decreases, right? If I'm 80, my muscle mass decreases even more. So your age is your independent, and your muscle mass depends on how old you are. So your question asks for what is the dependent variable. It is your amount of muscle mass, because your muscle mass depends on your age. Okay, let's look at the next one. Donna has made a table showing how the number of hours she spent studying for her science test influenced her scores on them. What is the independent variable in this relationship? So which depends on which? That's how I think of it. So we have her number of hours she studied and her test scores. Okay, her test scores. So do her test scores depend on how much time she studied, or does how much time she studied depend on her test scores? Well, if we look at this, we know that the more time we spend, the better our test scores. The less time we spend, the worse our test scores. So your test scores are independent, and your time studying is independent, and your test scores depend on how much time you study. So in this question, you want the independent variable, so it's her study time. Her study time is independent, okay? But her test score depends on how much time she studies. And then next, use the equation u equals -5 plus 4z. Determine the value of the output u as a function of the input z, which is the independent variable. Well, if my input is z, if I'm putting those input, you see that input, independent. Input is independent. So this question asks for the independent variable. So if my input is z, input is independent. So z is my independent variable. And those are a little confusing sometimes. Okay, I'd like to do one more question that I noticed a lot of students are getting and having a question about. Let's look at this next one, and your directions on here say comparing properties of linear functions in different forms. Okay, and we've got four different pictures. Okay, 4 different functions, so 4 different boxes, and we're asked about slope. Okay, so slope is your steepness of your line, it's your rise over your run. That's what this problem is comparing, slope. So if we look at this line is what we call it, it's falling, it's going down. Okay, it's falling. So this line has a negative slope. That means that when I calculate the slope using that formula, I'm going to get a negative number. Okay, and I can tell you right here, going from this point to this point, I have to go down 1, 2, 3, 4. That's down 4. And then I would have to go right 1. So my rise over my run is down 4. That's negative 4 over 1. I went to the right 1. Think of it like a little triangle right here. Okay, traveling from this point to this point. You have to drive on the street. And so my slope is negative 4, okay, of this line. If I have it in linear, written out in a linear equation, my slope is always the coefficient of the x. Okay, this is y equals mx plus b. There's the m. So my slope for this function number 3, my slope is negative 2. Okay, so for this one, the slope is 5. It told me the slope is 5. So the slope is 5, so m is 5 for my function number 4. And then for my function number 2, we're going to work it like we did this function table, because that's what this function table was about, constant rate of change, which is just slope. Okay, and so my input is my x's and my output is my y's. So let's come over here and let's see, okay, to get from this input to this input, to get from here to here, from here to here, from here to here, my x's, you have to add 1. Okay, to get from here to here, here to here, here to here, here to here, you have to add 1. So my slope is going to be my change in my x's, or what was the change here, which was add 1. Change in my y's over my change in my x's, which was add 1. So the slope of this line is 1. Okay, so these 2 lines are going to be going downward, and these 2 lines are going to be going upward. So these 2 lines are going to look like this, and these 2 lines look like this, because these slopes were negative and these slopes were positive. Okay, so now let's see if we can answer the questions. It says, which function's graph is the least steep? Is the least steep. So that means that the slope is going to be closest to 0. So the least steep is function number 2. Which functions have graphs with slope less than negative 3? Only one of them, because this slope is negative 4. So that is function 1. Which function has the graph with the greatest y-intercept? Okay, so we only really talked about slopes at first. Let's talk about y-intercepts. In written out in y equals mx plus b, the y-intercept is the number, the b. Okay, so this is the y-intercept. So right here where this line crosses the y-axis, that's the y-intercept. And so the y-intercept here, that dot right there, is on negative 5. And then for this one, it told me my y-intercept. My y-intercept is 4. So I know the y-intercept is 4 for this one. And then for this one, your y-intercept is hidden right there. When your x is 0, then you get your y-intercept. So for this equation right here, if we were to plot those points and draw that line and write the equation, this point right here is your y-intercept. So your y-intercept is -3. So it says, which function has the graph with the greatest y-intercept? So the greatest y-intercept out of all of these is the y-intercept of 4. And so the answer is function 4.